Welcome. Today, we are going to explore authentication in operating systems. The topic is verifying user identity and securing system access. In this presentation, we will cover what authentication is, why it's important, and the various methods used to ensure only authorized users can access a system. Let's start with the fundamental question. What exactly is authentication? Authentication is the process of verifying the identity of a user, system, or entity before granting access to resources within an operating system. Basically, it ensures that you are who you claim to be before you get access. Let's look at some key concepts. First, authentication confirms that users are who they claim to be. Second, it precedes authorization, which determines what users can do once they're in the system. Third, authentication is a critical first line of defense in system security. Lastly, it is typically based on one or more authentication factors, which we'll discuss in the next slide. Let's dive into the different types of authentication factors. These factors are categorized into three main types: something you know, something you have, and something you are. The first type is something you know. This is knowledge-based authentication that relies on information only the user should know. Examples include passwords, personal identification numbers also known as PINs, security questions, passphrase, and pattern locks. Next is something you have. This is possession-based authentication that requires physical items owned by the user. Examples include smart cards, security tokens, mobile devices, hardware keys like YubiKey, and radio frequency identification also known as RFID badges. And the final type is something you are. This is biometric authentication that uses unique physical or behavioral characteristics. Examples include fingerprints, facial recognition, voice patterns, retina or iris scans, and even typing patterns. Using a combination of these factors enhances the security of the authentication process. Let's take a closer look at password-based authentication. Password-based authentication is the most common authentication method in operating systems. Passwords are stored in hashed form, not plain text. This means the actual password is not stored, but a scrambled version of it is. Password policies enforce complexity requirements, like requiring a mix of uppercase and lowercase letters, numbers, and symbols. Salt values are added to prevent rainbow table attacks. A salt is a random piece of data added to each password before it is hashed, making it harder for attackers to crack passwords. Password aging forces periodic changes, encouraging users to update their passwords regularly. Here's an example of how Linux stores passwords in the etc shadow file. You'll see the username, followed by a string that starts with $6. This indicates the SHA-512 algorithm is used. Then there's a salt, which is a random value to prevent identical passwords from having the same hash. The hashed password is the encrypted password itself. And finally, the number shows the number of days since January 1st, 1970 that the password was last changed. Now, let's understand the password authentication process step by step. First, the user enters their username and password. Second, the system retrieves the stored salt for that username. Third, the system applies the same hashing algorithm to the entered password, combining it with the salt. Fourth, the system compares the calculated hash with the stored hash value. Fifth, if the hashes match, authentication succeeds. If they don't, authentication fails. The password authentication flow diagram shows this process visually. First, the user enters login credentials through a login form. The login form then sends these credentials to an authentication service. The authentication service fetches the corresponding password information from a password database. The authentication service will then generate an authentication result, which in turn creates a session for the user. Now let's explore biometric authentication. Biometric authentication uses physical or behavioral traits unique to individuals. It provides convenience, as there's nothing to remember, and it's difficult to forge or duplicate. It's measured by two key metrics: First is the false acceptance rate or FAR, and the second one is the false rejection rate or FRR. It is commonly used in modern operating systems and mobile devices. Here's how biometric authentication can be configured in Linux using PAM, which stands for Pluggable Authentication Modules. The PAMD common auth file is configured to use the pam-frinted.so module for fingerprint authentication. If fingerprint authentication succeeds, authentication passes. The pam-unix.so module is still required as a fallback. The try first pass option tries using the password from the previous module before prompting to streamline the authentication process. Now let's discuss multi-factor authentication, also known as MFA. MFA requires 2 or more verification methods from different categories to prove identity. It combines multiple authentication factors. It significantly enhances security posture. It protects against credential theft. It compensates for weaknesses in any single factor. A common example is using a password, which is something you know, plus a one-time code from an authenticator app, which is something you have. Modern operating systems provide built-in support for various MFA methods. Windows Hello combines biometrics with a personal identification number, also known as PIN. macOS supports Touch ID with password. Linux PAM modules can be stacked for MFA. Mobile operating systems often use biometrics plus a passcode. Smart cards are combined with personal identification numbers, also known as PINs. The security benefit is that even if one factor is compromised, attackers still need to bypass additional authentication methods. Now let's discuss single sign-on, also known as SSO. Single sign-on allows users to authenticate once to access multiple services. It reduces password fatigue and management overhead. It centralizes authentication management. It improves user experience and productivity. Common implementations include Kerberos, Lightweight Directory Access Protocol, also known as LDAP, and OAuth. Here's a simplified Kerberos authentication process. First, the client requests a ticket granting ticket, also known as TGT, from the authentication server. Second, the authentication server sends the ticket granting ticket encrypted with the user's key to the client. Third, the client sends the ticket granting ticket and service identification to the ticket granting server. Fourth, the ticket granting server sends the service ticket to the client. Finally, the client sends the service ticket to the service gaining access. Now let's discuss the current challenges and future trends. Some of the current challenges are balancing security with usability, protecting against sophisticated phishing attacks, securing biometric templates and preventing spoofing, managing authentication across distributed systems, addressing privacy concerns with biometric data, and handling authentication in Internet of Things, also known as IoT environments. Some of the future trends are passwordless authentication becoming mainstream, continuous authentication based on behavior patterns, artificial intelligence, also known as AI-powered adaptive authentication systems, decentralized identity using blockchain technology, quantum-resistant authentication algorithms, and context-aware authentication based on location, time, and device health. These advancements promise more secure and user-friendly authentication methods in the future. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.